Hello students, in this video we're going to work on composite functions. So, at the end of this lesson, you should be able to find the sum, difference, quotient of these functions. Lastly, you'll be able to write these functions in as a composite function. So below we have an arithmetic table of functions. Now this is just so you know what these symbols or how this notation looks. Now notice here it says f plus g of x. What this is saying is that you're taking f of x and g of x. Now if you forgot what these f of x and these g of x notation, what it actually means, it just refers to an actual function. The letter doesn't make a difference, it's just our way of denoting one function from another. So in here we have f minus g of x. Again, that means f of x minus g of x. So we're subtracting two different functions. F times g of x is f of x times g of x, and f divided by g of x equals f of x divided by g of x. Now a composite function is a little bit different. It looks like this. The little circle in between, we read that as of. So f of g of x, it just means you're taking the function for g and you're taking that whole function and substituting it in for f. G of x, the bottom one, just means you're taking f of x and you're substituting it into the g. So we'll take a look at those, so don't freak out just yet. Now we're going to do some adding, subtracting, multiplying, and dividing of functions. So here we've defined two functions. F of x just refers to the equation 2x plus 6, and g of x refers to x squared plus 1. So notice f and g just refer to two different functions. So if we're doing adding, we're just taking the functions for f of x and g of x and we're adding them up. So f of x is 2x plus 6. G of x is x squared plus 1. So all we're doing is we're adding those up. So we have x squared, there's no other x squareds, there's no other 2x's, and then we do have two constants, 6 and 1. So 6 plus 1 is 7, and this is your function. This is what happens when you add those two functions. Subtraction is the same exact thing, but I do want to caution you that when you're subtracting, you do have to be careful of your negatives. So f of x shouldn't change. Your g of x, because we're subtracting the entire function, you want to distribute that negative to each piece. That's why this x squared became negative x squared down here, and why this positive 1 became a negative 1 down here. So we now have negative x squared plus 2x plus 5. Multiplying, same exact idea. We're taking these two functions, f of x and g of x, and we're multiplying them. So in this instance, we're going to FOIL it to really get this down here, and then we're going to simplify and put it in standard form, which is this right here. Keep in mind that standard form just means we are arranging it from highest exponent to lowest exponent. Division, same exact thing. We're taking f of x and we're dividing by g of x. Normally we'd want to see if we can simplify. In this instance we can't, so we're done. Composite functions are going to take up a little bit more time. So again, we're going to stick with the same f of x and g of x functions. Now it says in the question, it says find f of g of x and g of f of x. So we're going to start with f of g of x. When we do this function, we're essentially taking the f of x, or we're taking the g, and we're substituting it into the x function. So here's how this should work. So we have f of x equals 2x plus 6. When we do the g of x, or f of g of x, it means we're going to take our x value right here that I'm highlighting right here in blue. We're going to take the value of g of x. The value of g of x is x squared plus 1. And we're going to substitute that in for x, and that's what we're changing in red. And we're just substituting it in. So f by g of x, when we distribute, becomes 2 times x squared and 2 times 1, and that's how we get 2x squared plus 2. And then we're going to simplify and get 2x squared plus 8. So again, let's look at another problem. This time we're saying g of f of x. Again, that means we're taking the function for f. So here's f of x. And we're taking that function and we're putting it in to the function for g. So basically it is a substitution in a substitution, or a function within a function. So our g of x equals x squared plus 1. When we do the part for f of x, what we're saying here is replace this x with the function for x, or for f. So instead of it saying x squared plus 1, it's saying 2x plus 6, quantity squared, plus 1. When we write that out, or expand that, we'll FOIL this, and when we expand it, we get 4x squared plus 12x plus 12x plus 36 plus 1. And when we add that up, we get 4x squared plus 24x plus 37. So if you're not quite sure if that makes sense, then make sure you rewatch this part of the video, try these U-try problems, and we'll take a look at them in class. That's all for now. I'll see you guys next time.